Today we are going to start the chapter Acids, Bases and Salts. Now before starting this, let's see how we can identify acids and bases in the lab. When these solutions are kept in the laboratory, then by just looking at the solutions we cannot identify which is an acid and which is a base. So what we are going to do, we are going to take some indicators and then we'll take some acids and some bases and we'll see what is the effect of an acid and a base on the indicators. Now what are these indicators? Indicators are those substances which change color when they come in contact with any acid or any base. There are some indicators which change their color. There are some indicators also which change their smell. So those kind of indicators are also called as olfactory indicators. When they come in contact with acids and bases, their smell or the odor that comes out from those indicators changes. So here in the first example we are going to take litmus, which is available in two colors, blue litmus and red litmus, and we'll take some acids and bases and we'll see the change in color. So let's start with that. So first we are taking HCl, which is hydrochloric acid, then H2SO4, then let's say acetic acid. And in the bases we'll take sodium hydroxide, potassium hydroxide, calcium hydroxide. Now if you take any red litmus paper or red litmus solution and you try to test it with or mix it with HCl, you take a drop of HCl on a watch glass and then add the red litmus paper or red litmus solution. What you will observe is there is no change. Same with sulfuric acid, same with acetic acid. But if you are taking a blue litmus paper, then that changes to red. Sulfuric also will change to red. This also changes to red. Okay. Now let's take the red litmus paper for bases as well. Red litmus paper with bases will change to blue for this also or this also. But if you take the blue litmus, there won't be any change. So what we can conclude from this experiment, that if you take the litmus solution or litmus paper with acids, the blue litmus turns to red in case of acids and the red litmus turns to blue in case of bases. So by taking this litmus paper or litmus solution, we can identify the acidic and the basic solutions in the lab. Now let's see there are what are the chemical reactions shown by these acids and bases. Let's take an example. In a test tube, let's take some dilute sulfuric acid, dilute H2SO4, that is sulfuric acid, and then we'll add few pieces of zinc into it. Now in the first case, what do we observe? We observe that some bubbles are coming out. Now what is this bubble? How do we get to know? If you bring a burning candle near these bubbles which are coming out, you will hear a pop sound. Now which gas gives us a pop sound? The gas is nothing but hydrogen. So when any burning flint or burning candle comes near hydrogen gas, then it gives a pop sound and it starts burning very faster because we know that hydrogen gas burns itself. Now what can we conclude from this experiment? You can see here I have taken acid in the beginning and I have added one zinc to it. Zinc metal I have added to it. Now after adding the zinc metal to acid, I am getting this gas which is hydrogen. So we can say that when metals react with acids, they produce hydrogen gas. Now apart from hydrogen gas, what else can be produced? Let's try to write a chemical equation on that. We'll take H2SO4 plus zinc. One product we are getting is hydrogen gas. Apart from hydrogen, what else is left? We have SO4, we have zinc. So there will be another product, that is zinc sulfate, which is nothing but a salt and hydrogen. So we can conclude that when acids react with metals, then salt and hydrogen gas are produced. Then you take sulfuric acid or you take HCl or even HNO3 can also be taken. So acids plus metal will give us salt and hydrogen gas. So we can generalize this like this: acid plus metal will give you salt plus hydrogen. Now let's see how the metals will react with a base. Now we'll take an example in which again we'll take zinc granules and then we will add it to the test tube which contains sodium hydroxide solution. Now this sodium hydroxide solution is a basic solution and then we will heat it. What do we observe? After heating, the reaction which is taking place between sodium hydroxide and zinc, that can be written this way: Na2ZnO2 plus hydrogen gas. Now this is nothing but sodium zincate. Now all the metals will not be able to react with the bases. Now over here also you are getting hydrogen gas along with the salt, but all the reactions are not possible. Alright, so now let's move on to the next type of reaction, that is the reaction of metal carbonates and metal hydrogen carbonates with acids. How do they react with acids? Now for an example, let's take sodium carbonate Na2CO3 and let's take sodium hydrogen carbonate, that is NaHCO3. Now we are going to add dilute HCl to both the solutions. Now once you take both the components like sodium carbonate and HCl in a test tube, you will see some gas will come out. Now if you pass this gas through lime water, then you will see the lime water turns milky, or the turbidity appears in the lime water. So what is the gas which turns the lime water milky? That is nothing but carbon dioxide. So we can conclude that one of the gas or one of the product which is getting formed is carbon dioxide. Now along with carbon dioxide we get water in both the reactions, and also definitely we are going to get a salt. What is that salt? NaCl in both the cases. Now you can observe that in both the cases the products which are getting formed are exactly the same. But when you balance this equation, you will get 2 over here and 2 over here. Other than that, the products which are getting formed, that is absolutely same. Similarly, other carbonates also you can take, and you will observe that water and carbon dioxide are getting formed along with the salt. Now when lime water is turning milky, what are the reactions which are taking place? What is lime water? Lime water is calcium hydroxide plus you are taking carbon dioxide. It gives you calcium carbonate plus water. Now this calcium carbonate is milky. This gives you the milky color. Now if you pass excess of carbon dioxide into it, what happens? Calcium carbonate plus carbon dioxide plus water is already there. It forms calcium hydrogen carbonate. Alright, now this calcium hydrogen carbonate is soluble in water. It is soluble in water. And the solution that we have is, it contains water. That's why the milky color or the milkiness of this solution will disappear. Okay, so what we can say, the entire process is, when you pass carbon dioxide gas through lime water, first it turns milky, and if you pass the carbon dioxide gas in excess, then the milkiness disappears because of the formation of soluble calcium hydrogen carbonate, and the milkiness appears due to the insoluble calcium carbonate. Right? So this is how the metals react with metal carbonates and metal hydrogen carbonates. I hope so far the reactions are clear to you all. Thank you.